Okay, this is what we covered in class on Thursday. Remember that by Sunday, 7.1 through 7.5, the homework, the second box on all the content things in eCampus should be finished. The other stuff, you know, the e-text, all that's for you to look at, but what I want to see is the homework being done, and do Sunday night at midnight along with your first quiz. All right, so we're going to go through exponents. Exponents, you just have to kind of remember the rules, and you have to follow. I mean, if you guys, we talked about PEMDAS, if you remember what PEMDAS stands for. P stands for parentheses, exponents, multiplication, division, and addition, subtraction. So this is the order when you're working through expressions you want to do things in. Parentheses, if you can simplify something in parentheses, you should do so. Exponents come next, so any exponents should be taken care of. Multiplication and division are on the same level. They're next, you work those left to right. In addition, subtraction, they're last, work left to right, okay? So we'll talk about maybe how PEMDAS fits into all this, but we have to know all our exponent rules, so we're going to review the exponent rules. So the product rule is when you take the product of two things, which reminds me, x to the fifth, x is called the base is on the bottom, and 5 is called the exponent, the thing upstairs, okay? So I just know the base is on the bottom. All right, so if the general rule is if I have x to the a times x to the b, you keep the base, one base, and you add the exponents, okay? So you just x to the a plus b, okay? So application, let's talk about why it's true. So x squared times x cubed. So if you think about it, x squared means x times x cubed is 3x's. So you have a grand total of 1, 2, 3, 4, 5 x's being multiplied together, so it should be x to the fifth, okay? So now if we multiply x to the 7th times x to the 12th, now the bases have to be the same to be able to multiply them, by the way. If it was x to the 7th, y to the 12th, there's nothing you could do with it. But since they're the same, we keep the base, don't mess with the base, and 7 plus 12 is 19, okay? So that's products. Sorry about that. Where'd it go? Okay. So now we're going to deal with quotients. Quotients means division. So if I have x to the a over x to the b, it turns out that is x to the a minus b. All right. So if I had something like x to the fifth over x cubed, I'm going to write this out the long way just so you can see it. 1, 2, 3, 4, 5 x's over 3 x's. And we know that 3 of them would cancel, and you're left with x squared. So we subtracted them. Okay, so for example, if I had x to the 15th over x to the 12th, well, 15 minus 12 is 3, so it's x cubed. All right, so power rule, these two people tend to mix up, so just be aware of it. X to the a raised to the b. So here you'll see I only have one base and two exponents. Here I have two bases. So, but when you have x to the a raised to the power b, this is x to the ab. So this is where you multiply the exponents when you have a power raised to a power. So for example, x squared cubed means x squared times x squared times x squared. So you have a grand total of 2, 4, 6 x's. So it's x to the 6, just like we expect. All right, so x to the 5th to the 4th power. Again, because it's a power to a power, you multiply them, and you should get x to the 20th. Okay. Notice I never mess around with the bases. I leave those alone. All right. Okay, so when you have a product to a power, so what they mean by if I have x, y, in parentheses raised to the a, when it's a product, I can distribute this through, so it's x to the a, y to the a, okay? This is not true. X plus y to the a. It does no, do not distribute, okay? Stay away from sums. So products, you can distribute the exponent through. All right, so if I have, I don't know, x, let's do 2x like this, 2x cubed, that means I'm going to cube the 2 and the x, because the cube applies to everything in the parentheses. So this is the same thing as 2 cubed times x cubed. Well, 2 cubed is 8, so it's 8x cubed. Okay. All right, so if I asked you to simplify something like 3x squared to the 4th power, all right, so you can distribute the power through, so it's 3 to the 4th, x to the, now this is a power to a power, so I multiply x to the 8, right? And you can plug it in a calculator, you're going to get 3 to the 4th is 81. Okay. All right, so that's the power rule. All right, so negative exponents are next. Negative, you know, like a lot of people don't care, you know, in science, but in math classes, they don't like the negative exponents, so we have to get rid of them. It's just kind of considered improper notation. And they're easy to deal with. Remember that a negative exponent has nothing to do with a negative number, nothing. It's about reciprocals, all right? So if I have x raised to the negative a power, well, we want to get rid of the negative. So basically it says flip and change the exponent to positive. That's all you have to do. So if you have x to the negative 5th, that means 1 over x to the 5th. Okay. And let's do another example. If I have 2x to the negative 3rd, right, that means 1 over 2x to the 3rd. And I can simplify that. 2 cubed is 8, so it's 1 over 8x cubed. Okay. All right, so you want to get rid of negative exponents. In math class, they really only like positive exponents. All right, so another thing, if the negative exponent is on the bottom, what do I do? Well, if it's on the bottom, we flip it and we bring it to the top, so it just becomes x to the a. Okay. So if I had 1 over x to the negative 2, if I flip it, it comes up top and it becomes x to the 2nd, x squared, okay? So, and you could combine these, like I'm going to give you an example. Let's say I gave you x to the negative 4th over x to the negative 2. Now, there's a lot of ways I could subtract the exponents, but you have to deal with negatives. So what I'm probably going to do is flip them first. So the x to the negative 4th comes downstairs and becomes x to the 4th. X to the negative 2 comes upstairs. All right, so now it's easier for me to deal with. If I subtract them, I get x to the negative 2. Well, I'll do it that way this time. But we don't leave negative exponents hanging around. It's 1 over x squared. Okay, and with quotients, a lot of time what I do is I just subtract them, and I know that the x is going to go with a bigger power. So 4 is bigger than 2, so I know the x has to go on the bottom. All right, so if I had something like, I'll write that over here, like if I had x to the 2nd over x to the 13th, well, 13 minus 2 is 11. The bottom's bigger, so it's going to be 1 over x to the 11th, right, in terms of degree. If I had x to the 15th over x to the 5th, the top is bigger, so it's going to end up on the top. Okay. All right. Last rule. Anything to the 0 power except 0 is 1, because 0 to the 0 is undefined. If you don't believe me, plug it into your calculator, you'll get an error. All right. So anything to the 0 except 0 is 1. Okay, so it can't be 0. All right, so if I asked you for what's 2 to the 0th, it's 1. All right, what's 3 to the 0? It's 1. Let's talk about parentheses here. I'm going to do 2 examples. There is a difference. Whoops, I don't want that parenthesis there. Okay, there's a difference between that and this. All right. So with this particular example, that 0 is being applied to both of those. So anything to the 0th power, it's 1. All right. So with this guy, x to the 0, remember the exponent gets applied first. So it's only being applied to the x, the thing right next to it. So here it was being applied to the parentheses, but here it's to the x. So x to the 0 is 1, so it's really 2 times 1 or 2. All right, so we're going to work some example with simplifying exponents. And like I said, the bases have to be the same. Like here, they're not the same, so there's nothing you can do with it. All right. Now, even when you're working with numbers, the bases have to be the same. You don't mess with the base. Most people will tell me this is 4 to the 7th or something like that. The base stays the same. The base is 2. So I keep the base. And then I'm multiplying, so I want to make sure that I add the exponents. So 3 plus 4 is 7. So it's 2 to the 7, whatever that is. Don't care. Okay. All right. So just be aware that, don't mess with the base, even if they're numbers. All right. So the second one is that power rule. I know that I can take the 2 and rewrite this like this if I wanted to. And I could simplify this. 3 times 4 is 12, and 12 squared is 144. Okay. All right, so C, real simple. I ask myself, what am I doing? I'm multiplying, and I know what I'm multiplying. I add the exponents, keep the base, so it's x to the, let's see, 4 plus 5 is 9. There we go. Okay. All right, so quotient rule. So basically what I do is, I told you with my hand, take the bigger one, it's going to go on the bottom because the bottom's bigger. So I just do 15 minus 8 is 7. So that's 1 over b to the 7th. Okay. So the thing with d, remember that d, this is really like d to the first power. All right. So c doesn't have any buddies or any c's, so he's going to stay the same. You have d to the 7th over d to the first. Well, when I divide that, I'm just going to subtract. So 7 minus 1 would be 6. That would be d to the 6th. Okay. All right, so again, with PEMDAS, the exponent only applies to the b's because there's no parentheses. The a's straight up cancel because they're exactly the same. All right, so we're left with b to the 12th over b to the 20th. So I'm going to subtract those. So 20 minus 12 is 8. Because the bottom is bigger, I'm going to put that exponent on the bottom. Okay. All right, power rule practice. So now we're doing a power to a power. So 2 to the 3rd squared, do not square the 2, leave the base alone to multiply the exponents. 3 times 2 is 6, so it's 2 to the 6. Whatever that is, which is 64. Okay. You can, B is just, you can distribute the cube through to both x and y, so it's x cubed, y cubed. All right, C you got to be careful of because you're cubing everything in the parentheses, including the 2. So this is 2 cubed, x to the 5th cubed. If I do 5 times 3, that's going to be 15. That's 8x to the 15th. All right, with negative exponents, again, in math class, we just want to get rid of them. So 10 to the negative 3 is 1 over 10 cubed. 5 to the negative 4, if I flip it 1 over 5 to the negative 4, it's 5 to the 4. Okay, it's all about taking reciprocals, nothing to do, with negative numbers. All right, so this guy, I would flip him first because I don't like negative exponents. So it's 3 squared over 2 to the 4th. And I can't do much with that. I'm just going to multiply them out. This is 9, 2 to the 4th is 16. And I can't do anything. All right, so they want me to rewrite these using negative exponents. So what's being squared here is 5x. So with negative exponents, I would write this as 5x to the negative 2. This one, okay, so this is x to the 1st. So I'm going to pull these downstairs and make a negative. So it's 1 over x to the negative 1, y to the negative 3. Okay, so this one, I'm going to flip them. So the y cubed will come up top and become y minus 3. It's all about taking the reciprocal. Z squared goes downstairs. Okay. All right, 0 exponent rule, easy. 2 to the 0, 1. That thing to the 0 is 1. Now this one we have to be a little careful of because the 0 does not apply to the negative. It only applies to the thing in front of it, which is the parentheses. So what I have is negative quantity 5x to the 0. So that's going to be 1 there. So it's going to be -1. All right. So this is a catch here. The 0 here is not applying to the 7. It's only to the x. So it's 7 times x to the 0. Well, x to the 0 is 1. Okay, so we have some practice. I'll work through those. If the first one, if I cube everything, I cube the -3. So -3 times -3 times -3 is -27. X squared cubed, you're going to multiply the exponents and you're done. All right, so I have options here. I think I'll get rid of the negative first. So this is 1 over 2x squared cubed, right? And then I can cube everything in the parentheses. So 2 cubed is, well, I'll just write it like that. 2 cubed x to the 6. So that's going to be 1 over 8x to the 6. Okay. So number 3 is probably one of the ones people mess up a lot because the -2 only applies to the x. It does not apply to the 8. So 8 does not come upstairs, only the x. So we keep x, we make x go upstairs, and we keep 8 downstairs. Okay, so now what we're going to do is number 4, we have a bunch of, we're going to multiply the powers through. So -2 squared is 4. X squared squared is x to the 4th. I got that one taken care of. Now we're going to come down here. 3 cubed is 27, and then x cubed. And simplify some of those x's. We only have 1 x left, so there we go. By the way, I should mention 4x over 27 is the same thing as 4/27 x. They do the same thing. All right, so that's the end of section 3. I'm going to stop this video and post it for you. This is what we covered in class on Thursday in week 1.